Okay, so this was the homework that I assigned last Tuesday, the 5th. So let me go through this stuff, you guys. So we've got circle the parts of the graph where the object is moving most quickly and explain how you got your answer. So what we've got here is we have a distance time graph. So if we're talking about when it's moving most quickly, we've got this C to D and then E to F. And so we know that those are correct because they have the steepest slopes. And the slope of a distance time graph is going to be our speed, our velocity. So that's how we get that one. Let's go. Let's move on. Okay. So now we have to circle the part of the graph where the object is moving away from the reference point. And again, it's a distance time graph. And so if we start at 0, so let me just draw you guys a little picture of what this looks like. So this person is starting at 0, right? So that's here. And then let's make another color. So let's make it like 6 seconds. They're at a distance of 6. So let's call this 6. Okay, so that's t equals 0. Then they're still at about 8 seconds. They're still there at 6 meters. So I'll just draw them there again. And then at about 11 seconds, they get back to 0. Okay, so the time that they're moving towards, there we go. Now when we're moving away from the reference point, right? That would be when we were going from the blue, so the blue to pink to green to orange is our thing. So blue to pink is moving away from the reference point of 0. That's this part. And then green to orange is going back. So it's just the blue to pink part. Next slide. Okay, which graphs represent a stationary particle, which is something that's not moving? Okay, so first of all, you guys, we've got X, 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 X. That stands for position, right? And then T, 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 T. So that's time. So we want to see where's the position not moving. So position is when time increases. So as time goes to the right, right? So as we move to the right, when do we have a position that doesn't change? All right, position is up and down, right? So we can't have it go up or down, then position will be changing. So we've got this one here. So this first one, 1. The second one, 2. Those aren't changing positions. This third one goes up and down, so that can't be it. And this fourth one also goes, well, the third one doesn't go down. The fourth one also goes down, so it can't be that one either. So we know it's 2 and 3. Let me erase that. Okay, so sorry. We know it's 1 and 2. Oh my God. We know it's these two. It's got to be these two. So the answer is 1 and 2. Nope. So that's this answer, C. 1 and 2. Next one, which graph represents a particle moving with a constant velocity that is not 0? So the last time it asked us when is something standing still, and this is the same, these are the same graphs. So we knew that 1 and 2 were standing still. Now it's saying, the question is, when is it moving with a constant non-zero velocity? So if we're standing still, we have a 0 velocity. Goodbye. All right, constant velocity, a non-zero. So we know that the slope of the line is equal to velocity. The slope of this line here, number 3, doesn't change. Same slope the whole way. Same slope. same or constant velocity. Okay, the other one doesn't have the same slope. So if we take a look at like what the slope is right there, it looks like that versus what the slope looks like right here, it looks like that. So you can see the slopes are changing. This one has a lower slope. This one has a higher slope. So the slope changes. So it's not constant. This is not a constant velocity. So it's only going to be 3. So your answer is, once again, C. Okay. So when does the moving object, it says, when does the moving object reverse its direction? So we've got position time and velocity time. All right. Let's look at the position time graphs first. We've got A and B are position time graphs. And we want to know, when does it reverse direction? So that means as time goes to the right, what's happening with position. So as time goes to the right, position only goes up here. This is only up. So this one can't be correct. Next one, as time moves to the right, the position only goes up. It's only up. Also not right. Okay, now we've got velocity. We've got 3 velocities. All right, so let's look. This number C. So now we only want to look at what sign the velocity is. We've got negative velocity here. In D, we start with positive, then negative, and then E, it's all positive velocity. All right, negative velocity means that we are moving in the negative direction. Positive velocity means we're moving in the positive direction. So negative velocity for C means we're only moving in the negative direction. That can't be right. Here for D, we've got positive then negative. So we move in the positive direction, then we change directions to the negative direction. So that's right. And then the last one, only positive. So we're only moving in the positive direction. That can't be right. So our answer is going to be D, which hopefully is just D. Yep, D. That's the answer there. All right, we've got a velocity graph, velocity time. Which one could have the position time graph? So based off of this velocity time graph, which one of these could be correct? Well, let's see. Let's just talk about what the velocity time graph is telling us right now. The velocity time graph is telling us that it's moving at a constant velocity, constant, non-zero velocity. Constant velocity means we move the same amount of distance every single second. So we're going to need, and we also know that the slope of a position time graph gives us the velocity. So we need to find a position time graph that has the same slope all the way through. Okay, so that's this one, has the same slope, and this one. They have, so straight lines have the same slope no matter what point you're at. This does not, because, let me erase that actually. Similar to what I showed you guys before, the slope right there is different than the slope right here. Different slopes. So different slopes, different velocity. That's messy. You can't see that, but that's okay. So nope for that one. So it's at 1 and 2. And that is C, 1 and 2 only. Okie dokie. So we've got position time graphs, and what we need to do is rank the graphs based on which graph has the greatest average speed. The average speed is calculated from beginning to end of motion. And we're talking about speed here, not velocity. So speed, we're going to do final position. So remember how we had, back in Unit 1, we had V equals change in X over change in T. That change in X is our final X minus our initial X over whatever our T is. So they all have the same, they all have a time of 10, right? So they're all divided by the same thing. We're just looking for what's the biggest difference between final velocity and initial velocity. Let me erase all that. Not velocity, final position and initial position. Okay, so when we look at A, the difference between the position at t equals 0 and t equals 10 is 0. It doesn't change. So this is going to be a speed of 0. Same down here, this position doesn't change. This is also a speed of 0. All right, here we go from a position of 0 to a position of 10. So our change in X is 10. Down here we go from a change in position from 2 to 5. Our change in X is 3. Over here we go from 30 to 0. So our change in X is negative 30. And then over here, this last one is tough. Our initial is 0. Our final is 0. Our change in X is 0. So we're just ranking it based on the positions because we're dividing them all by 10. It doesn't matter. So if you really want to know what the speed is, we've got a speed of 0 here, 0 there. 10 divided by 10 will be a speed of 1. 3 divided by 10 gives us 3/10. Negative 30 divided by 10, so that's a speed of 3, and then a speed of 0. So our ranking should be from greatest to least. It should be B. Then we have C. Not B, you guys. Come on. So E, which is here. C, which is there. Then we have D. That's our 3/10. And then all the rest of them, A, B, and F. These are all tied for last. Okay, and we got one more. How sure? Well, we don't have one more. I'm very sure of my rankings, so I'm going to say. But you can be different. There's no right answer here, my friends. Other than, don't forget, wind block, gold days, grill on help. Come see me. Let's talk about physics. I love it. Or math. Right, bye.